Hi everyone, let's talk about resources in TwinGate today, what they are, what they mean, and how to use them. So at its core, what a resource in TwinGate actually is really a split tunnel rule. A resource that is assigned to a user through a group of users determines exactly what traffic gets intercepted by TwinGates and goes through the TwinGate tunnel. We typically call what doesn't go through the TwinGate tunnel bypass traffic, and what goes through the TwinGate tunnel, TwinGate traffic. So there's many ways you can define a resource, but if you have to think of what a resource is, really remember that it is just a split tunnel rule that determines whether a particular traffic pattern gets intercepted by the TwinGate client and sent to TwinGate connectors. Now, a resource is assigned to a group or multiple groups of users. And so all of the users in a given group will have their traffic for that resource intercepted by TwinGates. The way you declare a resource is very important because that directly, again, determines whether traffic gets intercepted. A good example, I think, that people often forget at the beginning is that if your users are used to connecting to their production database or a database on something like db.corp.int, let's imagine that that same server has a private IP of 10.1.2.3. Well, you could create a resource for 10.1.2.3, and you could create another resource for db.corp.int, or you could create either one of those. The one that you should create entirely depends on what your users typically connect to, right? So if your users are used to connecting to the database using db.corp.int from the workstation, then you should create a resource as db.corp.int to make sure the traffic for db.corp.int gets intercepted by TwinGate. If they use the IP, create the IP style resource for your database. And if they use both, right? If some use the database or the fully qualified domain name version and some others use the IP address version, then just create two resources, one for each, so that you always intercept traffic, whether the traffic is addressed to the internal IP or the fully qualified domain name. That's the most important. The second thing is that when you define a resource, you can actually define port restrictions as well. And the third thing is that the traffic route that a connection will take entirely depends on what remote network your resource is attached to. Let's see this in practice a little bit. So we have a simple remote network here that resides somewhere in our AWS environment. We have a single connector, and within this remote network, we have 4 resources. You'll see that some of them are declared as fully qualified domain names. There's a single IP address here. There's a host name. There's an entire site range. But again, right, remember that this here, the definition of the resources is what determines what traffic gets intercepted. So I'm a user in this tenant. I am in the everyone group. Everyone's in the everyone group, including myself. This is me, and this group has access to a single resource. But you know what? We want to make sure that traffic gets intercepted by TwinGate for something else. So let's go to the list of resources we have. Also, by the way, a resource definition can match private endpoints, but also public endpoints, right? You can route any traffic you choose to a TwinGate connector, even if it's public traffic. So a good example of that is if we go to whatsmyip.org, this will give you my public IP address at home. This happens to be a public IP address in, I don't know if it actually says so anywhere, but where I live in Seattle. So this isn't a public IP of a connector because the traffic from my workstation to whatsmyip just goes through the internet. It doesn't go through a connector. But if I wanted to intercept traffic for whatsmyip.org, what I would simply need to do is add a resource that is going to match this traffic pattern. So let's just assume we're going to do a star what'smyip.org, and we'll call the resource what's my IP traffic. This we're going to attach it to my AWS remote network so that my connector in that remote network serves and routes all traffic from my workstation to what'smyip.org. I'm not going to touch the policy, and we're not going to touch those options yet. We're just going to create a simple resource. If I create a resource here and assign it to a group that my own user is a part of, which is the everyone group in this case, now let me connect my TwinGate client on my workstation to TwinGate. There we go. And now let's go back, right? So I'm connected. There is a rule here that says that it's going to intercept all traffic to what'smyip.org. So let's go to it. And now the IP address I get is very different. It's a different public IP address. If we take a look at the back at my TwinGate environment and go to remote networks and take a look at the definition of my remote network, as mentioned, I have only one connector, and that connector will have a public IP that is 3.134.82.6, which is this one. And that's because now, instead of the traffic going from my workstation directly to the what'smyip.org server, now the traffic gets intercepted by the TwinGate client, beamed to my TwinGate connector in AWS, and then exits out of that and goes to what'smyip. So from the perspective of the endpoint, what'smyip.org, I'm actually the connector. I'm connected as the connector to it, right? So again, remember that's how those rules or those resources work. There's, again, many ways to define a resource. If you really want to go towards zero trust, we typically recommend dealing with traffic rules on either IP basis or a fully qualified domain name basis, right? Say server1.corp.in, for instance, you could do that. But if you don't start with zero trust right away, what you can do is be a little bit broader in your resource definitions. And so if you use a fully qualified domain name or DNS style resource, you can add stars that substitute for 0 to many characters, very, very much like a regular expression. You can also use question marks. Question mark is exactly one arbitrary character. And you could actually use a combination of those. You could do, if your naming convention is that you number your servers on 2 digits, you could do server question mark dot, and maybe you have some subdomains. You could do that as well to cover a lot of ground. You could do something similar with IP addresses, actually. You could do entire CIDR ranges, right? So you could do something like this, for instance. Again, if you are coming from a world of VPN and you haven't mapped all of your networks, you can start broad and then you can narrow it down by looking at what people are actually trying to connect to. But that's what a resource definition is. The other subtlety is that you could, in this case, right, it's not really necessary because I suspect that what'smyip.org doesn't really expose anything beyond port 443 over HTTPS. But for private assets that are running multiple services, you could actually restrict the ports that are accessible to that endpoint, right? So you could do something like all ports, so 443, maybe port 80. You can define ranges and list the ports that should be accessible for your end users. You can also decide to block or allow ICMP if you want to toggle the ability to ping and not ping. The very final thing to mention is the presence of an alias, which only applies to either fully qualified domain names or single IP addresses. But let's say that you didn't have an internal private DNS and you wanted to make it easier for your users to connect to your private IPs without a DNS, you could define an alias, server1.int, for instance, so that when a user tries to connect to server1.int, it actually uses this IP, but the user doesn't have to remember the actual IP address. So you can add aliases to your IP addresses, and in case you have some super complicated stuff in fully qualified domain names, you can also use an alias to simplify complex fully qualified domain names that are hard to remember. That is essentially what a resource in TwinGate is. Just remember the routing aspect of it. That's quite important, right? A resource is attached to a remote network. A remote network always has one or more connectors. And so when you are accessing a resource in TwinGate through your user, the traffic for that resource will be routed to any of the connectors in your remote network. That's how the routing works. Now, a couple of examples I mentioned already. There's two meta characters that you can add in DNS style resources. The wildcard for 0 or more arbitrary characters, a question mark for 1 arbitrary character. That is up to you to define how you want to create your resources. But again, the piece I think that's super important here to remind people of is that if you create a resource for 10.0.1.0/24 and server1.corp.int happens to be one of those IPs, well, if someone tries to connect to the server1.corp.int fully qualified domain name, they won't be able to, because you would need a resource for this, right? If you only declare a site or range as a resource, people are going to be expected to connect using the IP address so that TwinGate knows that it needs to intercept that traffic. I think that's quite important. Now, last point on resources. We saw actually in the example I gave that you can protect technically, or you can intercept traffic for both private but also public endpoints. whatsmyip.org is a public endpoint in the end. So you can protect resources, you can protect assets that are privately hosted, but also that are publicly hosted. A very common use case for this is what we call app-gating of a resource that, for instance, GitHub, right? GitHub hosts their own servers. It's pretty rare nowadays that people are hosting their own Git infrastructure. So if you're a company that uses GitHub Enterprise, you could configure it so that GitHub Enterprise can only be accessed if you're on TwinGate. The only thing you need to do is you're going to need to create a resource in TwinGate to intercept traffic for github.com. So this could be the resource definition for that. Assuming you're using an identity provider, you should also create a resource for the identity provider to capture the actual traffic for the identity provider. And then in your identity provider, you can create a rule that will say that authentication to github.com can only be done if it is done from an egress IP that is one that corresponds to your connectors. If you configure it in that way, when a user at home that's not on TwinGate tries to authenticate against your enterprise GitHub, they won't be able to because the IDP will reject it as being an inbound connection that is not coming from one of the recognized IPs that are the connectors. But if your user first connects to TwinGate and belongs to the right group, then all of their GitHub traffic gets intercepted by TwinGate and sent to the connectors. Therefore, from the perspective of the IDP and GitHub, the traffic for that user comes from the connector, and as per the IDP rule, that traffic is allowed in. That allows you to protect assets that are publicly hosted that you don't have any control over, and restrict them to people that are connected to TwinGate, which implies that you can apply all sorts of policies to those resources as well. So you could add biometrics requirement to a SaaS application that doesn't support it. You could add that you require device verification for devices to be able to connect to your enterprise GitHub, even that's not something that GitHub Enterprise allows you to do by default. There's all sorts of things that you can do here. You don't need to rely on your identity provider to do this sort of app gating use case. but we find that it's a lot easier to manage if you do it from the identity provider itself. So that's typically our recommendation. But again, remember that resource definitions determine what traffic gets intercepted, but resources allow you to intercept traffic for both public assets and private assets. So that's what you should remember about resources in TwinGate. Let's review a few more configuration items on resources. The first one is how resources get displayed for your end users in the TwinGate client. So on the resource itself, if you click Edit and you click on the little globe that is next to the address of the resource, you'll have three options. Standard address, which just displays the list or the resource itself in the main list. You'll have the ability to select browser address, which gives the user the ability to click on the open in browser button. So that's assuming it's HTTP or HTTPS, and then it'll just open the default browser on the system and open it using that. And the final option is background address, which means the background address isn't going to be visible directly when you open a client. It's going to be hidden away under background resources, and we recommend to put in there the resources that are going to map to things that users don't necessarily need to connect directly to, stuff like your identity provider, Active Directory, things like that. Now, those are the three options you have that are going to determine how your resources get displayed and what level of options they have here. The other subtlety that isn't something you can control in the admin console because it's a per user preference is that you, in the client as a user, you get to select which resource you think is most important for you. And you have the ability to add any resource as a favorite, and it appears in the client right under the TwinGate button here. So you can add and remove any resource really to your client as favorites. And this is exactly what this is here. Now, background addresses, it's good practice to add resources that people are not going to connect to directly. Like I said, Active Directory and an identity providers are good candidates, but also anything with a wildcard or everything with a CIDR range is also a good one to put under background resources, because people are not going to connect to demo?star.lan, nor are they going to connect to an entire CIDR range. So it's very little usefulness in having them displayed right when a user clicks on their client. Now, on resource configuration, there's two more things you can do that are quite interesting, especially if you're trying to get closer to zero trust in your environment. The very first one is that when you define resource access, as you know by now, you assign groups to your resource, and the groups inherit access from that. But when you set access for a group to a resource, it doesn't have to be permanent access. It could be temporary access that eventually expires. So expiration of access is actually set on the resource itself and can be set per group. A good use case is if you have an on-call group with people and you periodically need this on-call group to have access to some production resources. What you can do, you can actually automate this process. You can define an expiration date using the CLI and the command line and the API. But what you can do is if I remove access altogether, and I decide to add temporary access to my on-call group, I can simply select the group, and then I believe here set an expiration, say same day. It's 1 p.m. here, so let's do an expiration at 5 p.m. today, grant access, and you will see once it's implemented, a little expiration notice next to the group for this resource. And so once 5 o'clock comes in, the on-call group will be removed from this resource and will no longer have access to the resource itself. Again, this can be automated. That can be done in the API and the command line interface. So you can implement those with any automated system. Now, if I remember correctly, I believe this is also visible at group level. So if you select a group, you'll be able to see all of the resources they have access to, but also if the access to those resources is going to expire. So that's the first thing you can do in terms of limiting access to resources from groups. The second thing you can do, which is more of a passive sort of set it and forget it feature, is this very interesting auto lock feature here. Now, an auto lock feature will keep tabs of who is connecting to your resource over time. One of the hardest things to achieve when you're trying to implement zero trust is to go from a VPN paradigm where everyone has access to everything all the time down to individuals have access to only what they need and nothing more, nothing else is visible. Because moving to that paradigm means that you know already and you have documented what people need, but also what people should have legitimate access to. But it's really hard if you come from a paradigm where everyone has access to all IPs and all subdomains and all fully qualified domain names in your network. So because of that, we've implemented a feature. We can take any resource that's applicable to single IPs and single fully qualified domain names, but also entire domains and entire site ranges, where you can define an auto lock feature that was going to be 30 days, 60 days, and 90 days, although we can get a lot more granular than that using the API. This is also something you can set with the API. What this feature will do is it'll keep tabs of who's accessing this resource and when. And if any user with legitimate access to this resource from, in this case, the contractor or the everyone group, if any user in those groups does not access this resource for a consecutive 30 days, then the user that hasn't accessed the resource for 30 straight days will be locked out of the resource. And what's going to happen when that occurs is the user is going to go to the resource and try to connect. And they're going to see a blocked screen that says locked due to inactivity to let the user know that they're being blocked out of the resource because they haven't been active. In which case, for now, the user only needs to click on troubleshoot, copy the information here. The information should be enough for the admin to realize that a particular user, in this case myself, is being blocked for a particular device on a particular resource that is here. And so what you can simply do in this case is this URL is actually just this one. So if I know that my user is being blocked, I could go and unblock the resource for my user, right? So in this case, I can go to the user. And I could take my resource here and simply unlock the resource so that the user can connect to the resource again. This entire request flow of a user being locked out of something and requiring access again, this is going to be added in TwinGate natively, but for now, the user will need to contact their admin with the right information so that the admin can unblock them. Now, if you're an admin and you're trying to figure out for a particular user that's having problems, take a look at their activity and what they're locked out of, you can at user level, but you can also do the same thing for a given resource. So if I go to my same resource that I tried to access before and download the summary, the summary is going to download two CSV files. The first one that is going to report on group access and give you a list of all groups that have access to the resource, what the group IDs are, but also if there's access is going to expire, which is the case because of our on-call group here, and the configuration of the auto lock. Now, the second one, this is a lot more interesting than this one, is for a given resource, who is locked out of the resource and who isn't locked out of the resource. So in this case, you can see that for this particular resource, a lot of folks are actually locked out of the resource because they haven't used it in a long time. And you can actually see the last access for my own user. I tried to access it, but was locked out, so I wasn't able to. You also have a little bit more information. If you unlock, you can see it here. So all of that information is available as reports from the admin console. And so to go back to the purpose of this feature, it is to allow customers to auto-prune access to resources across all users without really having to wonder if a person should have access to something or shouldn't have access to something. You can do a first pass towards zero trust by letting the autolock observe what people are connecting to. And then if someone really needs access to something, they will need to be unlocked, but hopefully that's going to happen very, very few times and give you extra visibility into what people need to access. A couple of things that are interesting to remember, right, is auto lock can be set at, it needs to be set at resource level and applies to all groups, although you can, if you want, you can set an auto lock for specific groups. So you could do something like your resource, a particular resource that isn't particularly sensitive is available to everyone, but it's also available to contractors. But you don't know if your contractors actually need it, and so you can just let it expire after 90 days, or in this case 30 days for contractors, without creating an auto lock for the rest of your employees. So that is also possible. And the auto lock also applies, like I said, to all types of resources and for all users that have access to a resource.